Okay. Hi, Miss Sparks. Let's see.
Hey, Caitlin. Sorry about that. I was getting ready.
Oh, I'm sorry.
No. You're fine. You're fine. You're fine. Um, and I have to tell my kids something. Will you guys set a timer for about 5 minutes and check the chicken, please? Thank you. Appreciate it. How's it going today?
Pretty good.
Good.
I haven't seen the video yet, so I don't know.
Oh, okay.
But
well, let's work on yesterday's.
okay.
And then the videos today are all there's 4 of them, but they're all really, really short. They're either right around 3.5 minutes or shorter. Some are like 2 minutes and 45 seconds. I think the longest one is 3 minutes and 45 seconds. So they're not too bad, but this way it kind of introduces each individual topic a little bit better, and you can kind of let that soak in and then move to the next piece.
Yeah. Okay. Sounds good.
But let's just work out a few of yesterday's worksheet. And the other thing to remember on that particular study guide is some of this was just vocabulary and notation. And as we work through this chapter, a lot of that will make more sense. There's just really no other way she always starts whining as soon as I get on Math Lab. It's like she wants to talk to my students too. It's my greyhound. She's trying to talk to you too.
Oh, she might hear my dogs. They're barking like crazy too.
Oh, I can't even hear yours. But like I say, as we move through the chapter, a lot of it will make more sense. It's just there's really no other way. You kind of have to introduce the vocabulary for sequences and series and all of that first. And then as you start understanding arithmetic sequences as we work with them, and then geometric sequences as we work with them, it'll start making a little bit more sense. But let's just work through the worksheet that I gave out yesterday.
All right.
And it will connect. Like when you watch that first video today, you'll be like, oh, okay, guess it's because we're adding to this same concept today. So what you'll do for the common difference, where it says find the common difference, and then the 3 terms in the sequence after the last one given. Yeah. So can you see everything okay? Okay. So what you'll do to find the common difference is take the second term, which is negative 46, and then subtract the first term. And then which that's going to be negative 46 minus a minus 36, which is the same as negative 46 plus 36, which is going to give you a negative 10. Okay. Now, a lot of times what you're going to want to do is confirm that that is, in fact, a arithmetic sequence, and you'd want to do the same thing by doing negative 56 minus a minus 46, which is going to exactly give you a negative 10. So the common difference for number 1 is negative 10. Okay. So what that means then is that I'm going to subtract another 10 for each additional term after the last one given. And the last one given is 66. So if I take another 10 from 66, I would have negative 76. And then if I took another 10 from that, I'd have negative 86. And if I took another 10 from that, I'd have negative 96.
Oh, okay.
Okay?
Yeah.
All right. Now, for number 2, the common difference, it looks like it's going down by 5. So you would do 6, just to be sure, 16 minus 21 equals negative 5. So that's going to be the common difference for that one. So to find the next 3 terms after the last one given is 6.
Yeah.
So if you take 5 away from 6, you're going to end up with 1. And if you take 5 away from 1, you're going to end up with negative 4. And if you take another 5 away from -4, you'll have -9.
Okay.
So that's how you do those. Does that seem a little clearer?
Yeah, that makes sense. I don't know, I wasn't absorbing anything yesterday. I don't know.
Monday after break, girl, I was right there with you. Probably the trickiest one, maybe out of these, the next one would be at number 4, when you're taking a -68 and subtracting 32. That's going to actually give you a -100.
Oh, okay. Yeah.
So it was a little easier to see the pattern here, but just to show you, if you have -68 and you do, hold on just one second. I would tell her I can kind of see. Oh, good. She's going to leave them on for another five minutes. Okay. Sorry. We're actually cooking dinner because Momo's in a recital. So we're eating an early dinner. So I'm sorry about that, Caitlin.
Oh, no, I'm sorry. I didn't mean to.
Oh, it's not a big deal. Not a big deal at all. I was trying to make it later in the afternoon for Math Lab for Algebra 2 because a few of the students actually have chemistry in the morning.
Oh, all right.
So that's why I was trying to move it to the afternoon. So,
okay.
Anyway. All right. Now, given the explicit formula for an arithmetic sequence, find the first 5 terms. So what you're going to do on that, and like I say, today, after you see today's videos, I feel like this will be even clearer. But the first 5 terms, all you're going to do is substitute for the n you're going to substitute n equals 1, n equals 2, n equals 3, n equals 4, and n equals 5 for each of these. So if I were to do that for number 5, if I were to substitute a 1n for the n, it would be 18 plus 10 times 1, which is 10. So the first term is going to be 28.
Yeah. Okay.
And then if I substituted a 2n for the n, 10 times 2 is 20, plus 18 is 38.
Okay.
And then you would just go on from there. So basically you can see that the common difference is that 10.
Okay. Why is the little n at the bottom of the A then?
Oh, very good question. And a lot of this is that's really good. And I'm glad that you asked that because I need to make sure we talk about it. The N is just basically, it stands for number. And so what that's saying is any number in the sequence. So it's just like a subscript N for any number in the sequence. But like if, and you'll see this a little more, if you have this, that's the first number in the sequence. If I had this, it's the 17th number in the sequence. If I had this, it's the 5th number in the sequence. So just by putting the N there, it means some number in the sequence. And whatever you're plugging in for the N is kind of that particular number or that position within the sequence.
Okay. Makes more sense. I was trying to like plug that in as, I don't know didn't know what to put it as. Is it?
And you don't have to like substitute anything in for that when you're doing that. Like, I mean, if you wanted to, like when you're working out the first term, just to kind of remind yourself, okay, let's say we're working on the 3rd term for this one. You could do A sub 3 equals 18 plus 10 times 3, just to kind of remind yourself that, oh, I'm working on the 3rd term.
Okay.
Yeah. So 18 plus 30, and then that's going to be 48.
Okay. Awesome, that one.
Okay.
Makes more sense now. Thank you.
Not a problem. Do you want me to work out any more for 6, 7, and 8?
No, maybe just like the first one of each little section.
In each section? Okay. So finding the common ratio and the first 3 terms. So the common ratio is going to indicate that this is a geometric series. as opposed to an arithmetic series. And a geometric series means that it's going to grow more exponentially. And so that's why you'll see when we get down to 13, 14, 15, and 16, instead of having a common difference, the common ratio is going to indicate that that's going to be an exponent because it's going to grow exponentially. So instead of subtracting the second term from the first term, you're actually going to express it as a ratio. So it would look like -8 over 2, which then reduces to -4, which says then for the next 3 terms in the sequence, I will multiply it by -4.
Okay.
As opposed to, you know how an arithmetic sequence we added? This time you're going to multiply that common ratio instead of adding the common difference. So your common ratio would be R equals -4. So that means what I'm going to do is I'm going to multiply a -4 times that -128, and I'm going to get 512 as the next term. And then I'm going to take 512 and multiply it by a -4. So 512 times -4 is a -2048. And then I'll take that 2048 and multiply it by a -4. And that's going to be a positive 8,192. Oops, sorry about that.
Okay.
Does that make sense?
Yes, definitely.
Okay, so just so the common ratio then for number 10, I would take -24 and divide it by -4. And that's going to give me a positive 6. So the common ratio is 6. So I'm going to continue this one by multiplying each one by 6, and that would give me the next 3 terms.
Okay. Yeah.
Does that make sense?
Mm-hmm.
Okay. All right. So now for number 13, just like with finding the next few or giving the explicit formula, find the first 5 terms, basically what you're going to do is just plug in that A sub n, once again, is just an indicator for some number within the sequence. So if I'm trying to find the answer for where n equals 1, then over here I would be A sub 1 equals -4 times, and then 2, and then 1 minus 1, that's going to be 0. So that technically any number raised to the 0 power is 1, right?
Yeah.
So that's going to be -4 times 2 to the, or times 1. So that first number is going to be -4.
Okay. Yeah. Okay, for the study guide, there's it's in vocabulary, and what's that little symbol? Okay, there we go.
Oh, the sigma symbol?
Yes, I did try and dig up the paper again, but there we go.
Okay, the sigma symbol, once again, was just an introduction to some of the syntax, you know, much like the A sub n and all of that stuff, some of the syntax and the vocabulary that you're going to be seeing and being exposed to, because it's kind of different than other things that you've been exposed to in math. The sigma symbol simply, and I don't make one very well, so this is actually stands for summation. And we didn't really work a lot with it yesterday. Just it's more of a syntax thing, but just to give you an idea, if I had n equals 1 and up here it was 8, that's telling me that they want me to add the first 8 terms of the series. And you're going to learn how to do that in today's lesson.
Oh, okay.
Okay. And so once again, it wasn't, so basically what it would do, and you'll see this in the in the video today. If I'm going to take this formula right here because we're going to be dealing with arithmetic ones. So what it would be saying is that you would substitute 1 in for where the n is, and then it'd be 2 plus 7. So the first number in that series is 9, right?
Yeah.
And so then the second number in that series, 9 times 2 is 14, 15, 16, right?
Yeah.
So 16. So technically I'm adding by fives, but you would take the first 8 terms of that sequence and add all the numbers together. And whatever that turned out to be would be the summation of this arithmetic sequence.
Okay.
And that's what it means. And today you're going to learn how to do it. And there is a shortcut, but you're going to learn that today. Instead of actually having to take each individual thing, like here we would have done 9 plus 16, plus we would have added the next would have been 21. And you would have done that for all 8 terms and then take each one of those figures and add them up. But there's a shortcut to doing it. But all of this was just to introduce you to syntax and what a sequence and a series actually are.
Okay. That makes much more sense.
So, and then today, in today's lesson, you're going to actually learn how to work with arithmetic sequences. Everything that you're going to do today is going to be more to do with 1 through 8 as opposed to 9 through 16. And then on Friday, we'll be dealing with geometric sequences.
All right.
But yes, it's like so much fun. Yeah, yesterday was just supposed to be light in introducing you to the idea of it because it's so different.
Yeah. Okay. It definitely, I mean, seems super easy now. I'm not really sure how I didn't get it, but
Well, sometimes when you're introduced to new vocabulary and also new syntax that you've never seen before, like the sigma sign, it can be a little daunting when you first see it. And so we didn't really want to add too much to it.
Yeah.
So and so hopefully now that we talked about it now, it will make a little bit more sense when you watch the videos today.
Okay. Much more sense. Awesome.
Is there anything else?
I don't think so. I think that's it. Thank you for taking your time. I'm sorry I didn't mean to interrupt.
Oh, math lab was supposed to be here. It's not a big deal. I enjoy people coming. It's so much more exciting than just sitting here by myself. But you have a blessed evening, and I'll see you tomorrow morning in class.
Okay, you too. Thank you.
Bye-bye.
Bye.
I wonder